Hey everybody, I got a really long video for you today. I'm sorry, but we're going to go over the properties of parallelograms and kites. And trapezoids are there, but we don't need to talk about them. They're not tested on. But there's a lot. There is a lot of information in this chapter. These notes are going to be posted with the quiz and everything, but no, come back. All right. So we're going to be mostly and almost entirely talking about this left side of the flowchart here. So a quadrilateral is any shape with four sides, right? Quad means four, lateral, quadrilateral is four sides. So a polygon with four sides, polygon just means a shape. But we're going to be focusing on this left side right here. Parallelograms, which then go into rectangles and rhombuses, which all of them go into squares. So there is a whole lot of properties and they can be applied in so many ways. And this is a very confusing chapter. It's also going to be the longest quiz I've ever given you because there's a lot to test when it comes to this topic. But what I'm going to do is I'm going to make this a little bit smaller. Hopefully you can still read it for the most part. That's not what I wanted to do. I can go ahead and cover up that. I don't need those. Maybe I can make it bigger like that. All my careful planning for nothing, right? There we go. That's not too bad. Of course it changed size right when I moved it, right? All right, there we go. So here are properties, and we're going to go through them one at a time. And I'm going to regretfully use MS Paint because well, that's the only kind of software I have to do this with. So here we are. Alrighty. So this shape is actually called a rhombus, R-H-O-M-B-U-S. It's, you know, it kind of looks like a square that got like pushed over at the top. But it's, you know, it is what it is. This is a rhombus. It's not super different. They usually use this shape to signify parallelograms. So you'll see sometimes you'll see this rhombus shape in text and it'll say like, it'll have this rhombus shape and then say, you know, ABCD is whatever. Well, they mean parallelogram ABCD, right? They use it as a symbol, just like we use little triangles for triangle ABC. They'll use this rhombus as a shape for parallelograms. Well, let's just go through and kind of like mark up, and I'm going to delete things as we go, but we'll get through this. So parallelograms have all of these six properties. All parallelograms have these six properties. So every rectangle also shares all of this, rhombuses share all of this, and squares share all of this. But let's go through. It says both pairs of opposite sides are parallel. Well, I mean, duh, it's a parallelogram. So what they're saying is this side, those are some really thick lines. There we go. Those are some really skinny lines. Let's try one up. There, that's good enough. And now, of course, I want to change the color. All right, so this little symbol right here, these little arrows, are to signify that that is parallel to this, right? And then this guy, and they'll do a situation like so, parallel to this guy. There you go. So this side is parallel to this side is parallel to that one, you know, opposite sides are parallel. Another way to draw a parallelogram, or in this case like a rhombus, is, do I want to do it here? Yeah, why not? So you remember this situation from a long time ago? Two parallel lines in a transversal, right? Transversal being the line that crosses two parallel lines. Well, if you draw a parallel line, so I've got my transversal here, if I draw a line parallel to the transversal, what's created in the middle there is a parallelogram. So that's why they're called parallelograms, because this situation right here creates one. Like 4 parallel lines will create a parallelogram. Okay. So it also says both pairs of opposite sides are congruent. So this side is equal to this side. And this side is equal to this side. Right? That's not too hard. I mean, we're talking about rectangles. You guys know that about rectangles. Opposite sides are congruent. They're equal to each other, right? All right. Now let's get, oh, well, this one's dumb. One pair of opposite sides are parallel and congruent. Yeah, duh. I mean, if this is parallel and to this, and this is equal to this, then they are both parallel and equal. Thanks. So, moving on. The diagonals bisect each other. So what in the world is a diagonal? Well, diagonal is exactly what it says. It is a line that goes from one point to its opposite point in a diagonal fashion crossing the shape. These are diagonals. Anytime you see, oh, that's not what I wanted. Anytime you see a question where they'd have a parallelogram, rectangle, square, rhombus, and they have the lines in the middle, look at all the diagonal properties, because that's what they're doing. That's what they're going to do to you. They're going to use the diagonal ones. But for number 4, it says the diagonals bisect each other. Well, what does it mean to bisect something? It means to cut it in half, and those halves are equal. So when you bisect something, you cut it in equal halves. So AC, this whole line going from A, trace it all the way down to C, is being cut in half by this line, cut in equal halves. As in this, from A to the point we don't have here. But if there was a point right there, this line goes through it and cuts AC in half from A to this point and from this point to C. Since this is the midpoint, oh, I just said it, oops. You can say since this cuts it in half, it's the midpoint, but I just said midpoint. So yeah, that's the midpoint of both lines. Now, diagonals bisect each other. That doesn't mean they're equal. They just cut each other in half. So this will equal this, but not necessarily half of AC. So from A to midpoint, midpoint to C, cut in half, they're equal. B to midpoint, midpoint to D, cut in half and equal. All right. And then get rid of those. Both pairs of opposite angles are congruent. Both pairs of opposite angles. Well, if I got an angle here and an angle here, they are considered opposite because they are across the shape from each other. And since they are considered opposite, whatever this angle equals, so will the other one. If this was, I don't know, 120 degrees, then this one over here would have to be 120 degrees. Opposite angles are equal. Now going along with that, the last one is probably the most tested because it is the most confusing, right? That's how your test makers work. Is it confusing? Yes. Give it a bunch of questions on the test. So, I'm gonna mark them all real quick, just because, why not? All right. It says consecutive angles are supplementary. Consecutive angles. Well, what in the world does that mean? So what that means, what consecutive means is one after another, right? In consecutive order, 1, 2, 3, 4, one right after another. So how does that apply to this? Well, I took my finger and traced the figure from one angle to another, that's consecutive. They're next to each other. They're one right after another. So D and A are consecutive angles. If I kept going from A to B, A and B are consecutive angles. That's how this works. Consecutive angles are basically next to each other. So what you can do, let's say this was, this one would be 100 degrees, right? It says consecutive angles are supplementary. So I know D and A are consecutive, right? If I go from D and drag my finger across to A, that's the next angle I run into, so that is consecutive. And it also says they are supplementary. Supplementary means that two angles add up to 180. So if D is 100 and D plus A equals 180, then what is angle A? Well, you can solve it. 180 minus what you have will equal what you're missing. So we know A is 80 degrees. Well, we can keep going, right? I said if you keep tracing it around the figure, if I go from A to B, A and B are consecutive angles. From A to B, right, next angle, and they add up to 180. Well, if this is 80, and these two add up to 180, then I just do 180 minus 80, right? And then same thing, from B to C. If I drag my finger from B to C, they must be consecutive. They're the first angle I run into, so they add up to 180, and that's going to leave this with 80. Now, if you notice, we said in the previous little property, both pairs of opposite angles are congruent, right? Well, D and B have to be equal. They're opposite angles. Oh, would you look at that? A and C have to be equal. They're opposite angles. Oh, look at that. They're equal. So these two properties kind of go with each other. You're going to see them used very, very, you're going to see them used in conjunction very often. So, all right. I want to, do I want to explain more of the properties? Or do I want to do some questions based on just parallelograms? Let's do questions based on just parallelograms. Okay, cool. This will be the first one. Okay. So let's look at the information they gave us, right? We're looking at a parallelogram. It says EC from E to C is 12. That's what they're saying, at least. Oh, I'm annotating, that's why. I went from Microsoft Paint to the zoom function, and it messed me up. Can I make it bigger? I don't think I can. All right, whatever, it's 12. From E to C is 12. And then BE, from B to E, is 15. And that's all the information they gave us. And then there's blanks for AE and DE. So we need to find AE and DE. We need to find their lengths. Well, this is a parallelogram, right? And these are the diagonals. And in a normal parallelogram, there's only one property that deals with diagonals, that they bisect each other. They cut each other in half. So if EC is 12, what's AE? What's the other side, the other half? Same with BE and DE, right? If BE is 15, what's the other half? Well, most of you probably figured it out. If this side is 12 and it was half of the whole thing, then this other side is 12. And if BE is 15, then DE, the other half, has to be 15. Since they bisect each other, right? They cut each other in half. Another way to look at this is that this half is equal to that half. I say that because you're going to get a lot of algebra in these questions. For instance, let's say EC wasn't 12. Let's say EC was 2x plus 2. And then let's say they gave us AE as 3x minus 3. Right, something simple. And then they say solve for x, which is exactly what I put on the test, on the quiz following this. Solve for x. I think everything is solve for x. Sorry if you don't like to do that, but it is what it is. So we got 2x plus 2, 3x minus 3. How do we solve this? In geometry, anytime you see a variable, anytime you see x, y, z, whatever, all you have to do to solve is to find an equal sign. Find an equal sign. In geometry, most things are going to be equal to each other, or they're going to add up and equal 180. That's pretty much how it goes. I mean, there's, of course, plenty of exceptions, but most of the time, either two things are equal to each other or they add up and equal 180. That's where you get a lot of your algebra and geometry. So if EC is 1/2 and AE is the other half, and they're equal halves, then they're equal to each other. 2x plus 2 equals 3x minus 3. So from there, we just solve, right? And I'll do it real quick. I always like to move the smaller x, so I don't have to deal with negative x's, negative variables, because that's miserable. So 2 is smaller than 3. So we have 2 on the left side equals x minus 3 on the right side, which is nice and easy because all we have to do is add 3 because that's the opposite of a positive. We get 5 equals x. So we set them equal to each other and then some basic algebra and you are Dunyan rings. So that is way more, this is basically what your quiz is. There's a bunch of questions like that. So also on the quiz, if you get a question wrong, it's okay. I put insanely detailed descriptions of how to work through each individual question. If you get it wrong, there's a big block of text explaining everything to find the answer. So if you don't feel like you know the answer, it's okay. Get it wrong and then view my explanation. It'll help a lot. Okay, so that was going over the diagonals bisecting each other. Here's another big one. So we need to solve for x, y, and z. We need to solve for all of them. So how are we going to do that? Well, we're dealing with angles in a parallelogram, which means we're looking at the last two properties. Both pairs of opposite angles are congruent. Consecutive angles are supplementary. Hold on. Both pairs of opposite angles are congruent. If this is 65, which angle is opposite 65? Because opposite angles are congruent. They're the same. So we know x, right? X is opposite 65. It's on the other side of the parallelogram. So we know that is also 65. Cool. How do we figure out y and z? That's the question, right? Well, y and z are opposite each other. So we know they're equal, but if we don't know one of them, we don't know either of them. So then we move on. Consecutive angles are supplementary. Okay, so angles next to each other, like B and C, or C and D, or D and A, or A and B, those are supplementary. They add up to 180. So I know that y and 65 add up to 180. Y plus 65 equals 180, and there's your equal sign. right? We can solve for this pretty easy. Minus 65 from both sides. Y equals 115. I'm right with that? Yeah, I'm right. Y equals 115. And if y is 115, we can go back to this whole both pairs of opposite angles are congruent, right? Y is 115. Going across the parallelogram, we're going to hit z, which is also going to be 115, right? Or you could solve it this way. This is 65, and it was supplementary with y. Well, this is 65, and it's supplementary with z. You can do the exact same thing, right? They're both going to give you 115. All right. So that's how these things are going to be applied. That's how they're going to be used and thrown at you. Let's talk rectangles. This one shouldn't be too complicated for everyone. You guys know rectangles. You all know rectangles. It's a rectangle, right? So one, it has all the properties of a parallelogram. So all of these properties apply. Every single one of them. They also say it has a right angle, a singular right angle, right? Well, if it has a singular right angle, if we did all the other properties of parallelograms, you find out something interesting. So one, both pairs of opposite angles are congruent. If this is 90, then the angle opposite it is also 90. And then, going along with this trend, consecutive angles are supplementary. If this is 90, then C, right, and B will add up to 180. So 90, I mean, some of you already, you're like, I get it, I know, but I'm just going to spell it out for everyone else. 90 plus C equals 180, right? Minus 90 from both sides. You get C equals 90. Because, well, you know, it's a rectangle, 90. So once one angle in a parallelogram is 90, oh, they're all 90 because consecutive angles, opposite angles are equal, all that other stuff, all those properties we just talked about, okay? So it has a right angle, which means it has 4 right angles. Then the last little bit there is the diagonals are congruent. Diagonals are congruent. So, I mean, it's exactly what it says, the diagonals. So AC is equal to BD. They're the same. But don't forget that they also cut each other in half. So half of AC in a rectangle is also equal to half of BD. So if there is a point in the middle, do I have a point? Yes, I do, maybe. Yeah. So if there was a point in the middle and it had a letter E, why not, right? You know what? No, I don't conform. M. Okay. So in a rectangle, the diagonals are equal. In every parallelogram, the diagonals bisect each other. So AM is equal to MC, BM is equal to MD. Cool? I say cool because we're about to do a question on it. All right, I made this one needlessly complicated on purpose so that those of you who are having issues with algebra can see how I solve it and all that stuff. Okay. So in this question, it says AC, that is this entire line, is 2x plus 10. The information down here says that BD, this entire line, is 6x over 2 minus 5. Oof. All right. How do we solve for x? Well, we know that the diagonals in a rectangle are congruent. I mean, it's pretty much the only special property. I like rectangle questions because they're almost always about the diagonals. Every time you see a rectangle question on an exam, it's going to be about the diagonals or something really silly like, this is 12. What is the side down here? And it's also 12. That's how rectangles work. But yeah, so the diagonals being equal are pretty much the only special property about rectangles that get attention. But being that AC is a diagonal, BD is a diagonal, so these two equations are equal to each other. So 2x plus 10 equals 6x minus, and then I gotta draw the thing. Why'd I make this so complicated? Okay. So there are two ways to deal with this situation right here. You could multiply both sides by 2, get rid of this, right? And then solve accordingly. I, however, don't like that because you're more likely to make a mistake. Because when you multiply both sides by 2 to get this out, most people forget to multiply this extra number by 2. This minus 5 would get multiplied by 2 as well. Most people forget that. So I like to go a little weird, I guess, in my opinion, with this. I like to get everything away from the fraction first, then deal with the fraction. So I'm looking at this minus 5. Well, the opposite of that would be plus 5, right? I'd plus 5 to both sides, which would give me 2x plus 15 equals 6x, and it's going to be, over 2. Now, I like to do that because anytime I think about algebra, I was never really good at math, ironically, in high school and whatnot. It always took me the longest to do, but I didn't make mistakes. I didn't make mistakes because I wanted to make sure that I did everything right. That's why it took me so long. So I have all these little processes in the way I do algebra and math that basically basically the fewest amount of functions possible means the less chance for mistakes. So if I get rid of this 5 here and it's just this, then when I multiply everything by 2, I'm just multiplying these by 2 and I'm done. Because this is going to cancel. So I'm going to go ahead and multiply everything by 2 on this side. And then you multiply everything on this side by 2, right? But that's not a big deal because, I gotta move my 2 and my line. There we go. So this isn't a big deal because these two cross out, right? If you multiply something by 2, then divide by 2, then you did nothing. Nothing happened. You changed to nothing, right? So all I have to do is distribute this 2, and then it looks like a normal equation, and that's what I like. So 2 times 2 is 4, 2 times 15 is 30. I'm going to move it over here, or down here. So we get 4x plus 30 equals 6x. And from there, it's a nice, easy equation, right? I'm going to move the smaller x. And don't freak out if the smaller x is on the right side by itself. Move it anyways, because in math, we have this crazy thing that represents nothing. And, it's called 0. 0 represents nothing. So if I moved the 6x over here, it would just be negative 2x plus 30 equals 0. Don't be afraid to do that. It doesn't make the equation any harder. You're going to end up doing the same stuff. But in this case, we've got 30 equals 2x. We're almost done because, well, that's almost done, right? How do you get rid of that? What's the opposite of multiplication? Well, you divide. Divide both sides by 2. And you're left with 15 equals x. Now, there's a trick in algebra. There's a saying that if you were given infinite time on any algebra test, whether you knew algebra or not, you could get them all right. Because you could take numbers and plug them in until it made sense. The problem with geometry, though, and algebra and geometry, is that unless you know how the number or how the two equations are actually related, you can't really do that. If you didn't know these two were equal, like answer choices wouldn't really help you, would it? So you have to know the property, you have to know how they're related to each other. And like I said, most of the time they're either going to be equal to each other or they're going to add up to 180. But one way or another, that's going to work out. Okay, we're almost through the practice problems. There's only one more practice problem, right? Yeah. Okay. All right, so let's slide over here to rhombuses or rhombi. I really wish the plural was rhombi, but it's rhombuses. But whatever, who cares? So this is a rhombus, right? You got to go through the properties of a rhombus. Well, one, it's got all the properties of parallelogram, which I already drew all up on this thing. And then two, it's got all of its sides are congruent. Okay. So every side is equal to every other side. Very much like a square, right? So I said that a rhombus is like a square where the top got pushed over. Well, this kind of makes it look even more like a square, doesn't it? All the sides are equal. In a rhombus, all the sides are equal. So that's easy. But then we get into the fun stuff. The diagonals, right? So we draw these diagonals out and we get some weird properties. For instance, the diagonals are perpendicular. What does that mean again? I hope you remember. Perpendicular means it creates a right angle. When two things are perpendicular, then they make right angles. They make 90-degree angles. So the diagonals are perpendicular. That is, perpendicular means two lines that cross and create 90-degree angles. So all of these angles here, all four of these angles are 90 degrees. I mean, my picture isn't exactly the most accurate, like at all, but whatever. All of these are supposed to be 90 degrees. You forego my drawing. Okay. Keep going, keep going. Come on, zoom. There we go. Okay. So our diagonals are perpendicular. And then it also says the diagonals bisect opposite angles. The diagonals bisect opposite angles. Now we already dealt with bisect, right? The diagonals bisect each other. That means to cut in equal halves. So let's go to angle B real quick, right? Angle B is this entire angle. What they're saying is that this diagonal line cuts this an angle in equal halves. Diagonals bisect the opposite angles. Cut these in equal halves. So what they're saying is that if this was, I don't know, 50 degrees, what would be the other side? What would be this side right here? Well, if it's cut in half, it also has to be 50 degrees, right? And yeah, easy peasy, right? Well, let's look at a question. So I got X and Y in here, so we can solve both. Woohoo! Let me dial it back a little bit. There we go. Okay, let's do X first, right? It's alphabetical, it comes before Y. So let's do X first. We have a rhombus. The diagonals are drawn. And we've got this angle right here in the middle. 3x plus 60. So again, we're always looking for an equal sign. The second you see a variable, the second you see x or y, you're looking for an equal sign. Something is equal, right? Well, going over to our properties of rhombus, there are only two that deal with diagonals. Diagonals bisect the opposite angles. This is not an opposite angle, right? This is not an angle of the rhombus, so this fourth one doesn't apply. But the diagonals being perpendicular matter. This angle is supposed to be 90 degrees. It's perpendicular, which means 3x plus 60 has to equal 3x plus 60 equals 90. It has to be perpendicular. It has to equal 90. So from there, we can solve it out. Minus 60 from both sides. 3x equals 30. And then how do you get that 3 away from the x? Well, oh, it didn't do that. Just because I'm ridiculous. Okay. There we go. So we divide both sides by 3, and that'll give us our final answer of x equaling, well, what's 30 divided by 3? Shazam. X equals 10. Always looking for an equal sign. Okay. So now let's go down to this corner here. Now, I wrote the diagonals bisect opposite angles off for this question because this is not an opposite angle. Coming down here, this is an opposite angle right here. So we're probably, we are dealing with diagonals bisect opposite angles. So the whole angle is 40. Crap. The whole angle is 80. Whoops. All right, so the whole angle C, right, is 80 degrees. I said that the whole thing is 80 degrees. And we got 2y right here. We need to figure out what 2y is equal to. All right, just screwed it up. But if the whole thing is 80, and the diagonals cut these in half, what is half of 80? Well, that's what 2y equals, isn't it, right? 2y is half of 80, so 2y equals 40, half of 80. And then you would solve that just the same way. Opposite of multiplication is division. So we divide both sides by 2. And we figure out what y equals, which happens to be 20. So these are the kinds of questions on your test. This quiz is algebra heavy because this topic is algebra heavy. And if you haven't realized, they always make geometry harder by just throwing in a bunch of algebra. But before I get to the final, like the finale or whatever, let's talk about squares for a very hot minute because, well, you're not going to see a lot of questions on squares. You're not going to see a lot of questions on squares because, frankly, they're easy. Squares are really easy. Squares have all the properties of parallelograms, rectangles, and rhombuses. What that means, yeah, that'll work. So what that means is that all the sides are equal, right? Yeah, that'll be good. All the angles are 90 degrees. And the angles are cut in half, which means all of these guys, all of these halves are half of 90 or 45, right? So each half is 45. Every angle is 90. There's also a right angle here. Oh, this square looks pretty. But yeah, so you've got your right angles from rectangle. You've got your perpendicular diagonals from rhombus. You know all the sides are equal. That's from rhombus. You know the diagonals are equal because that's from rectangle. You also know that they bisect each other, so you know that all of these are equal. Right? You've got the 4 right angles in the middle. You got the 4 right angles on the sides. You know they're cut in half on the sides, which means they're 45. All the properties are here. But the thing is that when it comes to a square, everything is equal. Everything is equal. So they don't do test questions on it because once you know this, you know all of these angles on the inside are 45 degrees. You know that these are 90 degrees. Like there's not really a lot of questions that are really like thought-provoking or interesting that you can do with squares because everything's equal. It's equal. So you won't see a lot of questions on squares. You'll see some. You'll probably see like 1, maybe 2. But in general, they're going to stick to parallelograms, rectangles, rhombuses, and squares. And then the last little part I'm going to touch on are kites. So kites are, it's a kite, like you would fly a kite. They're really, really boring. There's not a lot of information. There's not a lot of things about kites. So, oh, I didn't know I could do that. All right. Let's try that again. There we go. So a kite is exactly what it sounds like. Sorry, I looked off for a second. It's a kite, like, you know, a flying kite. They aren't parallelograms, so none of those properties apply. They only have a couple of properties. It says both pairs of consecutive sides are congruent, but opposite sides are not congruent. That is a really, really, really crappy way of saying this side equals this one and this one equals this one, and obviously they're not equal to each other because these are way longer than the top, right? But number one is basically saying these 2 sides up here are going to be equal, and the 2 sides down here are going to be equal, not equal to each other. It says the diagonals are perpendicular, so they form 90-degree angles. So when you draw these lines, they're going to form a 90-degree angle, and yeah, of course they do, because it is a gorgeous little cross of 90 degrees. That's also where the sticks would be if this was a real kite. You put the sticks in this exact fashion. So, and then exactly 1 pair of opposite angles are congruent. What they mean by that is angle B and angle C are equal angles. A and D are not equal angles, and they don't even look equal, right? They don't even look similar. But B and C, the 2 wingtips is what I like to call them. Your 2 wingtip angles are going to be equal. Now, you're not going to get a lot of questions on kites, almost at all. Pretty much never. Like, you're not going to get questions on kites. You may get a question on kites. I mean, on the quiz, I put 2 just in case, but on the actual FSA, I think you might see 1. And then the last one, right kite, all the properties of a kite and has a right angle. Well, the right angle would be right up here. It would be where A is. This would be your right angle, and then everything else would be exactly the same. So I don't know why it has its own distinction, but it is what it is. So that is properties of parallelograms. Trapezoids aren't tested on at all, so you don't have to worry about them. But I have them there just in case. I don't know if you're interested. I just didn't edit them out. So there you go. But properties of parallelograms, rectangle, rhombuses, and squares is so important and so tested on. And when I say so tested on, I mean I think it's about like 10 or 11% of the FSA. So like a whole letter grade is based on this. And I mean, if you hadn't figured it out, the majority of the test is talking about triangles because we did that for like half a year. But properties of parallelograms is almost 10% or 11 or 12, something like that. So this is a very important topic. That's why this video is so long. You know, I apologize for that, but the more complicated these topics get, the longer my video explanations would be. I mean, if we were in the classroom, this would be like 2 days of lecture or 2 or 3 days of note takings and lectures and me asking you questions and all that stuff. But since we're not in that situation, I have to record a long video. So, but we're done. The quiz is the longest quiz I've ever put out. I think it's 11 questions. I know it's crazy, right? So much. Not really. Don't be like that. But yeah. go ahead and start working on this as soon as you can, and good luck. Keep working hard, and we'll get through this soon enough. Peace out, y'all.